For every packet on the back page, I have a quote by somebody, and I repeat that quote on the inside front cover on page 2. And this quote is not a science quote, so to speak, but it does use one of the words, which is, in this case, topography. And topography means lay of the land, or how the hills and valleys form, the shape of the land, topography. And so this guy, Mr. Frederick Evans, is using that science term, but he's not really trying to teach science with his quote. Try for a record of emotion rather than a piece of topography. What he's actually trying to say here is, in your life, don't make it a goal to own lots of land and lots of stuff. That's not your record that really counts, but rather a record of emotion. How do you affect people around you? How do you handle your own emotions? How do you, dignify yourself properly and all that? So that's a more precious kind of goal to use. So it's a lifelong lesson kind of a quote, but not a science quote. The next thing that's always on page 2 is this kill a myth feature, where I write down some kind of a myth or misunderstanding that lots of people have, and then the true fact. So a lot of people think that Kansas is the flattest state of the country, but no. Florida is the flattest, and Illinois is a close second. We have vocab list, and you'll see that same list over and over and over at the beginning of every lesson. And a magic trick. This is on YouTube if you want to see that. It's kind of cool. A ball or a wheel that rolls uphill, and how do you think they do that? Turn the page. On page 3, we have a bunch of videos that are optional. These are not required, but they deal with the topic at hand, and I hope that they are more enjoyable. You can see the titles there: Steepest Street, a really steep snowboarding video, steepest hills in the world, steepest sledding hill, extreme off-road vehicles that are designed to go up very steep ditches and things like that. I thought you might enjoy those if you want to take a peek. Next page. We have flashcards. So whenever you want to start studying for your concept quiz, you can turn to the front of your packets, and there'll always be some kind of review material. Most of the time they're flashcards, but not all the times. When I print out these things, I print them double-sided, so the answer is on the back. Just remember that when you print them out, you may or may not have that feature on your printer, and so you may have to recopy the answers on the back of your flashcards. But there's lots and lots of flashcards here to cover all the different topics. Let's go on to the first lesson in the packet, lesson 13. This is page, I believe it's page 20. How do I find the altitude of places? Purpose, I will learn how to read the altitude of a place off of a map. Relevance, this is a basic reason for having topographic maps. Geologists and other earth science researchers will use topographic maps to study an area. There are also people who have the hobby of something called geocaching, where they go out and they hunt for buried treasure, so to speak. Now, the treasure is not gold or coins or anything like that. The treasure might be just simply little tiny army men, or a little tiny toy jewelry, things like that. The treasure is not the actual goal or the fun part of it. The fun part is trying to find it when you are out in the middle of the woods. Other people like to go off-trail hiking, basically the same as the geocaching, but they try to get from one place of a national forest to another place without using the trails, but rather just using maps and a compass and things like that. And one of the maps that they will use is a topographic map. And those are the maps that show you where the hills and valleys are. and so you can get across the land without the trails. Success. I'll be able to tell how high any point is on a map. Today's grades, you'll have a wrap-up 13, and we have homework 13 as well. So we might be running to the very end of the 45 minutes here. Just remember that you'll need to turn to those. Next quiz, next week, Wednesday and Thursday, lessons 18 and 19. Does anybody have any questions over anything we've done so far in the previous packet? You can go ahead and shout it out, or you can type it into the chat room. If you do not have a packet, you can go to the photograph of my teacher desk and click on the blue and green folder, and you can download it there. I suggest that you download it as a Cami so that you can draw your notes, type your notes in. There is a text box feature on Cami so you can type things neatly and quickly. Or there's the pen features that you can use to draw your words in. Okay, part 2. Part 1 we've done. We have introduced the new packet. We've gone through the first pages. Let's see, looking at the quizzes, you've gotten your results already as soon as you hit submit. Remember that if you choose to retake your quiz, you can do that at any time, but I suggest that you don't retake it until you've done more studying. Figure out what you got wrong and review some more, because remember, if you retake it and you get a lower score, you get the lower score. Your first grade disappears forever and ever and gets replaced by the more recent score, whether it is higher or lower. Okay, part 2, Lego classwork activity. Materials, a Lego landscape. That's this right here. I have a Lego mountain, a Lego, we're going to call it an island. We're going to pretend this is the green ocean, the green sea. Okay, well, sometimes the ocean looks greenish. And graph paper. We have graph paper right here. It didn't print really well. You can't see it well because the ink just wasn't very dark. It's not glare because of my light. It's just a bad printout. Okay, task. Look down on the landscape and draw the edge of each layer of bricks. The height of each brick is about 10 millimeters. Label each line with its height above the table. Okay, so we're going to draw this, and we're going to have it in this orientation. Let me have it look more straight down. There we go. Okay, so we're going to look at this first edge, and we're going to draw a line that mimics it over here. This first edge is 1, 2, 3, 4, 5, 6, 7, 8 bumps long. This edge is 8 bumps long. So I'm going to draw a line here that's 8 squares long. 1, 2, 3, 4, 5, 6, 7, 8. And then this edge goes over 3 bumps. 1, 2, 3. So I'm going to draw this to the east, 3 squares. 1, 2, 3. And then this edge goes down 2 bumps. 1, 2. So I draw the line going south on my map, 2 squares. And then to the east, 2 squares. And then we have a long side going north. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the north side, 5 wide, closes up that shape. So everybody should have that kind of a thing drawn on their paper at this time. Does anybody need more time to do that? Go ahead and blurt out, please wait, if you do. Okay, now we're
Please wait.
Oh, okay.
Okay, I'm done.
All right, now we're going to look at the red sides. Again, starting at the upper left-hand corner, just because I like it. Notice that it is one bump down and one bump over. So I'm going to start it right there at that spot. And from that spot, I'm going to go down 4. 1, 2, 3, 4. So 4 squares. 1, 2, 3, 4 squares down. And then 1 square to the east. 1 square. And then 2 squares south. And then down here, the edge is going east-west, 2 bumps, 2 squares. On the east side, it's straight up and down, and the length, I believe, is going to be 6. 1, 2, 3, 4, 5, 6. So 6 squares. 1, 2, 3, 4, 5, 6. And then the top edge goes from side to side, 3 bumps, 3 squares. And then the blue edge at the top is 1 by 1. Now, each one of these edges is 10 millimeters up. So I'm going to label this as 10. And the next one I'm going to label 20. And the next one I'm going to label 30. And I can label those anywhere I want along those lines. I could do it down here as well. Notice that the top of the hill is a little tiny rectangle, and we have a little tiny rectangle here that represents the top. In real life, when we're doing this with hills, the top of a hill is going to be more roundish, oval, kidney bean shaped, whatever. It's not going to be, but some kind of a small circle. And so that's going to be the top of hills on a topographic map. There's another thing we can learn about this. Let's look at the steepness. Here on this side, on the top side, it is very steep. On the bottom south side, it's not as steep, more gradual. Steep, gradual, steep, gradual. So on the top where it's steep, the lines are close together. On the south side, where it's more gradual, the lines are farther apart. So we can tell 2 things from topographic maps. We can tell where the hilltops are by having small circles, We can tell where the hills are steeper because the lines are closer together. Those are the two main points of today's lesson, and we'll see that over and over here. Okay, let's do another example. Something a little bit more complicated. Here we have two hills. Well, it starts off as one hill and then it breaks off into two. So let's first do the yellow layer. I gotta zoom out here a little bit. There we go. Again, starting in the upper left-hand corner for no real reason, it's just convenient for me. This side here goes down quite a ways and then jig-jogs just a tiny bit. So it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes down 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my first section. 10 squares down. And then we have a little jig jog where it goes to the east 1 square and then down 2. So there's to the east 1 square, and here is down 2. On the south side, it's going to go to the east 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it goes north 1, 2, 3, 4, 5, 6, 7, 8. These numbers here are the number of squares in each section. These are not the elevations, not the height of this edge. These numbers are not the height like we did before. This is just the numbers of squares to help you out. Okay, then it goes over 1 and up 2, and then over 1 again and up 2. And then draw the north side going straight across. Next, we have 2 blue layers. We have a square 4 by 4, and we have a blue rectangle that is 5 by 6. Let's put those in the right spot over here. The top blue square is 1 step away from the edge on the top and 2 steps away from the left side. So that means it's right like that. That's corner. We're going to have a 4 by 4 square with 1 space on top, 2 spaces on the left. It's a lot of numbers being thrown at you all at once. 4 and 2 and 1. But anyway, there's your square in the right location for the second layer. The other blue rectangle is again 1 spot away on the north, but this is 5 down and 6 across. So 5 down and 6 across. 5 down, 6 across. The red layer. On this one, it's a 2x2 square. And here it's a 3x4 square. I'm going to erase these little numbers here because they're going to get in the way. They were just there to tell you how big each side was. And lastly, we have a gray layer up here. That's 1x2. Okay, so once again, like we had before, the tops of hills are shown as circles, or in this case, squares, but you know, a closed small shape. In real life, they're going to be circles and ovals and kidney shapes and all that kind of stuff. And we can see that the lines here are all the same distance apart, so that means that the model is all the same steepness, no matter which way you go. Okay, let's label the heights. This line represents an edge that is 10 millimeters high. This one is 20, and then 30, and then 40. These lines over here, we can do the same thing, 10, 20. It only goes up to 30 because it's a shorter hill. The taller hill has more lines to it, more circle square things. Okay, so this is roughly a topographic map. In real life, obviously, things are not stair steps like this. They're smooth inclines and all that. And so the numbering is going to look slightly different, slightly, but the general idea is the same. This square here represents the edge right here that is all the same height above the green base. This edge is all the same height. This line represents that same height going all the way across. This little tiny rectangle here represents the edge of the gray stick or gray brick. And all of this edge is the same height of 40 millimeters above the green base. And so we have the line here connecting all of those equal height spots on the gray brick. All right, with that in mind, let's turn the page and let's look at something a little bit more realistic about landscapes. So here we have a landscape of a riverbed and a valley on each side of the river. And then we have the flat land above the valley, a little bit of a hill right here. Above this, we have the topographic map that corresponds to different areas. Number one, see how let's see here, time out for a second. It is 10:40 and we get out of here at 10:55. Okay, it's going to be close. See how the curvy lines on the map correspond to the curves of the hills and valleys below it. So here we have the curvy line here on the map, and that corresponds to the curvy slope cliff of the valley. Here's the curves of the hill, and that corresponds to the curves on the map. Number two, notice how the white lines on the land are all the same elevation or same altitude. Elevation and altitude are synonyms. So right here we have a line that's, oh, let's say 20 feet above the river. Here's the river. So every point on this white line is 20 feet above the river. This line here, let's say, is 40 feet above the river. So every spot along this white line is the same 40 feet above the river. Okay, so lines are all the same elevation or altitude. They connect locations of equal altitude. These lines and the matching lines on the map are called contour lines. Contour lines. Each line can be labeled with a corresponding altitude. This way we can look at a map and see how high each spot is. Each contour line on a map represents a step up or down along a hill. Note how the steep hills match up with contour lines that are very close. Here we have a very steep line in the diagram of the land, and the corresponding part of the map up here, the lines are very close together. Here, the land is rather flat. You have to walk a long distance before you go up 20 feet in altitude. And so that's shown by having the lines far apart in the map area. So let's write down that information down here in line number 5. Note how flat areas match up with contour lines that are far apart. Next page, number 6. The difference in heights between contour lines is called the contour interval. In our Lego examples, the contour interval was about 10 millimeters. I think every single time you guys look at a topographic map, the interval is going to be in feet. A different number of feet with each map, sometimes 10, sometimes 5 feet for each line, sometimes 20 or 50 feet. It's all sorts of numbers, but they're all nice, easy numbers. They never have 7.5 or 2 3/4 as their intervals. It's always nice numbers like 5, 10, 20, 25, 50, that kind of stuff. Number 8. It would be nice if every line on a topographic map was labeled with its altitude. Sadly, they are not done this way. Some contour lines have extra dark and have an altitude written on them. The rest are lighter in color without numbers. You have to figure out the elevations of these lines. So for instance, looking down here at this map, we have a dark line here labeled 700, and we have another dark line labeled 800, but these lighter lines are not labeled with numbers at all. Now, there is a very good chance that a lot of you can just look at this and you can already know what this number should be and what this number should be. But let's go through the steps for everybody else. Step A. First, you find the difference between the known dark lines. So the known dark lines here, once again, were the 700 and the 800. So the difference there is 100. Step B, count the number of steps between dark lines. So to go from this up to there, from the 700 to the 800, I have to go 1, 2, 3, 4, 5 steps. Step C, divide the difference by the number of steps. 100 divided by 5 is 20. So that means that each line, the difference between each line is 20 feet. And so we can then count up by this. Count up by 20 in our diagram here on the left side. So if this is 700, this dark line, the next line up is going to be 720. And then we have 740, 760, 780, and then we match up again with the 800. Now, you might have been able to figure out that 20 just by looking at it. If you're good at math, That's a distinct possibility. But go ahead and label things and make sure that you come out right. If you thought immediately, oh, that goes up by 25s, you'd be 725, 750, 775, 800, and then another 800, and that wouldn't make sense. So double check your work if you need. Okay, number 10, find the elevation of each. Letter B, we can see that it is on the line that we labeled 740. D, we didn't label that one. What's it going to be? Write it down. You should have written 820. Letter E, where is that? Down here. Write down what you think that should be. You should have written 680. The difference between lines is 20, and this is going in the downhill direction. So that'd be 680. M, over here. M is on the line, so it's going to be 40. Just by looking at this, can you tell what the other lines are going to be? Go ahead and label them. You should have labeled them as 30 and 50. You could do that by going through all these steps, or hopefully you could just tell by looking at it. Another number 10. I have two 10s there. Oh, well. If a spot is between lines, estimate to be halfway. Between the contour lines. So this letter C. Now I don't have a dot there, but it does not matter if the dot for C is there, or there, or there. All of these dots are going to be estimated the exact same way, halfway between 760 and 780. So that's going to be 770. That's just the way they estimate it. It is true that most likely this dot here is going to be closer to 760, like 765, 764, something like that. Yes, that would probably be more reasonable, but they don't do it that way. That's not how a geologist would do it. Even though it's closer to the 760, we take the exact middle number. Middle. Okay. Anybody have any questions on that page? Feel free to blurt it out or type it into the chat box. Next page. What is the altitude of point B up here? Go ahead and figure that out on your own. Okay, point B is on this line right here. And as I follow it along, it's going to get labeled as 900. Refocus on today's purpose. I will learn how to read the altitude of a place off a map. Have we done that? Yes, we have. Okay, now let's extend this idea. The difference between two altitudes is called the relief. The relief between C and D. Let's see here. I need to connect these things right here and there. Okay, that's a little bit better now. Okay, D we see is 1,000, but how high is C? Let's see here. We go 800 to 900 to 1,000. Each step is 100. So that means that this line here is going to be 1,100, 1,200, 1,300, 1,400, 1,500 for the C. So the relief is this altitude, 1,500, minus this altitude, 1,000. So 1,500 minus 1,000, 1,500, that's for C, minus the D value of 1,000 gives us a relief of 500. Find the relief between B and D. Well, here's B, that was at the 900. D is 1,000, so the difference between those is 100. 1,000 minus 900. Find the relief between A and B. A is over here at 900. That's what B was too. B's on the other side, but it's still 900. To go from A to B, you have to go up and down, but those cancel each other out. A and B are the exact same height above the ocean, 900. So we have 900 minus 900 equals 0. Some spots have their exact altitudes marked at a dot or a similar thing. These are called benchmarks. Number 17, benchmarks. And you can see there's a benchmark right here. They say that spot is 1533, I think it says. Or did I say 1633? I think it says 1632. Okay, so that's the exact height of that spot right there. Estimate the height of the mountaintop at point X. Okay, going up with our contour lines, we see 11, 12, 13, 14, 1,500. So that means that this should be 1,600. X is even higher than that. So what we do is just like we have a spot in between, we go a half a step up. So if each one of these steps is 100, half a step is 50. This will be 1,650 here. Now that kind of makes me confused. It says here this is 1632, so that must be wrong. This must be 1532. Now that makes more sense. That must have been a typo. Okay, it is 10:55. That's the end of class, and I finished just in the nick of time. Please remember you have homework 13 and wrap up 13. Bye-bye.